Good morning, students. We are going to continue with system programming unit 1, right? So in the previous class we discussed about micro flowchart for add instruction. Sometimes in the exam it may be asked for a say some other instruction, let us say an subtract instruction. So you don't have to worry. The only other question which was asked so far is only subtraction. The only thing here we will be doing here is, so instead of saying working register is equal to working register plus MBR, you have to say working register is equal to working register minus MBR. So that's where you will perform the subtraction operation. So that's the only difference. So addition instruction, add instruction or subtract instruction, accordingly you can draw the flow chart. Yes, we will go on to the next topic now. The next topic we are going to discuss today is data formats. So you have two different formats here in IBM 360. We are going to study two different formats. One is going to be the data format. The other one is the instruction format. What do you mean by data format? It's like your data types in C. When you study data types, you will say there is integer data type, there is double. Okay. So the like this, we are going to see some of the data types here in IBM 360. Right. Only thing is the names are a little different here. Right. So first one is short form fixed point number. It's known as first data type here is short form fixed point number, which means there is no decimal places. That's it. It's a short because of the length or the size of that particular data type. Right. So what is the size of the data type? It's going to be 16 bits. So it's going to be 2 bytes or 16 bits is the size. So you can say, whenever you're remembering, first remember the name short form fixed point. Immediately you have to remember 2 bytes or 16 bits is what you should remember next. So these two things, if you remember, the diagram can be easily drawn by you. So that you don't have to mug up the diagram. You just remember the size of each and every data type. Right. So what is the first S there? S there means sign bit. So you can use 0 and 1 0 for positive numbers and 1 for negative numbers. That will be the sign bit, right? Apart from that, you will have 1 to 15. So you have other 15 bits you can have, that is be used for data. Okay, so you can have data in represented in 15 bits, and the 16th bit is nothing but your sign. It's the 16th bit. So we are going to say 0 is sign, from 1 to 15 is the actual number, right? The second type is going to be same as that of a short form. Only thing is it is a long form fixed point number. So here form fixed point number, the only difference is going to be the size of the data type. So there I said 16 bits. Here it is going to be 32 bits or 4 bytes, right? 32 bits or 4 bytes. Right. So here also it's the same format. S is nothing but your sign bit. So 0th bit is your sign bit. 1 to 31 is all going to be your number. So you can represent a bigger number here. Bigger integer can be represented because you have total of 31 bits plus 1 sign bit. So much of space you have to store a number. But you cannot store decimal numbers. This is only for integers or fixed point numbers. Right. Before going into the decimal packed and unpacked, I will move on to the floating point numbers. So we had fixed point number, now we are going to say floating point. So short form fixed point we studied, now we are going to study short form floating point, long form floating point number, right? So what is short form floating point number? So one thing you have to remember is the size, 0 to 32. I'm sorry, 0 to 31, which is 32 bits. So size of the short here, short itself is 32 bits. Okay, long is going to be 64 bits, right? First thing you will remember is short and long. In that, you have to divide them into two parts. One is called as the character part, the other part is called as a fractional part. Character and mantissa you have studied in max, the same thing here. So character and then the fractional part. So it's, you take a number, you take the integer part separately and the fractional part separately. So what is the format? First is going to be the sign bit as usual. Next one is going to be the character part of it, and the second half is going to be the fraction part of it. Okay, but what is the size? So 1 bit for sign, right? 8 bits for your character part, 8 bits for your character part, and the remaining 8 to 31 for your fractional part. 8 to 32 I'm sorry, 8 to 31 for your fractional part. This is going to be how a number is going to be stored. Yes. Will I be able to give examples? Yes. So even for short form fixed point number, 1 is a sign bit. When I have to give an example, I will say 1. If I say 1 in the first bit, which means it is a negative number, then I have to again go with some randomly, you can write an example, random numbers, 0011 so how many bits you should have? From 1 to 15 bits you should have. So that will be an example. So you can give your random examples if possible. Convert that random example into a decimal number and give, but that will be it will be a bit more time consuming. As of now, how many ever bits are there, just give an example with so many bits. That will be more than enough, right? Yes. So long form floating point number. So sign bit floating point itself means it has two parts. One is character part, other one is the fractional part. So only difference here between the short form floating point and long form floating point is that the size. So that is the first one is going to be 32 bits. The second one is going to be 64 bits. So but you can see the format doesn't change. The format has sign bit. It's going to be 1 bit. First bit is the sign bit, 0th bit. Then you have 1 to 7, which means 8 bits. You're going to have what? For character. Okay, so in this case 8 bits, 1 bit is sign, the other 7 bits are characters, right? Similarly, from 8th bit to the 63rd bit, all these are going to be your fractional part. Yes, here also you can give numbers, give them random zeros and ones. That will be more than sufficient. Yes. So what have we seen so far? Short form fixed point number, long form fixed point number. Short form fixed point, how many bits? 16 bits. Long form fixed point, 32 bits. Short form floating point, 32 bits. Long form floating point, 64 bits. Yes. Yes. So we will go to the next one. Logical or characters. Here logical data type is used for the characters. Here the what do you mean by character? String data type is what we call it in C. So that is what we are going to here see as characters data type. So what is character data type? Very simple. So how many ever alphabets you have, each alphabet will be represented using what? 1 byte of information. So 8 bits is required to represent every character. How many characters I can have? I can have up to 256 characters, right? Each character is going to be represented using 8 bits. So this is see the format. CH here means what? One character I'm going to place there. So how many bits are required to place one character? 0 to 7, 8 bits. Okay, next character 8 to 15, right? And so on. So how many characters I can have in total? I can have 256 character. The symbol which is here is nothing but it is going to mean that there are it's going to be it's going to go on, right? It's not going to end there is what is the meaning here, right? So it's not a small box actually. So I cannot just go on drag and say I cannot show you 256 bytes maximum. So I can say this can be adjusted. This is adjustable window. Yes. So far we have seen 5 data types we have covered so far. Short form fixed point, long form fixed point, short form floating point, long form floating point, and characters. Done? Yes? Yes. So last we will keep it as this packed numbers. Packed and unpacked. So what do you mean by packed decimal number? Is so what I can do is I wanted to sometimes in my programs I wanted to store BCD numbers, okay, which is nothing but binary coded decimal. So I want to use binary coded decimal. I will tell you, give one small comparison here. The short form fixed point number which we have here, the short form fixed point number. So when I have to represent say a number 79, I'm going to represent a number 79. You have to directly convert number 79 into binary. So you'll do that binary calculation, right? So we will do that. 79 will be here. Then you will say, I have to convert it into binary. So divided by 2, right? And so on. So what you get there is going to be the direct conversion of 79. But when I say it is binary coded decimal, BCD number systems, then what I should do? I can only use what numbers with can be represented using 4 bits. So I cannot simply divide 79 by 2 and find out the binary equivalent. Instead 7 I will first convert into binary. So what is the binary format? 111. So I have to represent 7 in 4 bits, which becomes 0111. 9 again I have to represent in 4 bits. So 9 and 4 bits will be 1001. Yes, so that's how we are going to represent the numbers here. Okay, each and every digit in a number has to be represented in 4 bits. It's the only difference, that we call it as a packed number system. So what is the format here? So it's going to have only 4444 numbers. Last bit here will be the sign bit. Okay, sign bit also is going to be 4 bits. So remember, it is a packed number. Every thing is going to be represented in 4 bits. Okay, so I understand. Yeah, 7 I know how it is represented. Likewise, I know all the numbers how it can be represented in 4 bits. How can a sign be represented in 4 bits, right? That's what I have. That's why I have written here. Okay, so you would have noted this and you would have thought of what is KF and what is BD? Is there anything to do with a coffee break, right? So KF here means C can be used, A can be used, F can be used, E can be used. So these are all what? These are all hexadecimal numbers. So hexadecimal number C, A, F, E can all be used for representing positive. So sign bit here can take values C. If I say C, positive number. If I say A here, positive. I can use any one of this to represent that my number is a positive number. If I use E, I can use yes. Okay. So say let us say I'm going to use A. So how will I use A? A has to be represented in how many bits? 4 bits. So what is the A? A means what? 1 0. 1 0 is A. How do you represent in 4 bits? Right? How do you represent 4 bits? Convert A into hexadecimal number into your binary form. That will be your 4 bits. Right? So that is what we will be doing. Similarly, if I have to represent a negative number, I can either use B or D. So B and D are used for representing negative numbers. You understand? That's the format of packed decimal number. The next one is unpacked number, right? The only difference between packed and unpacked is, so for first thing is, here also we are going to be representing it using 4 bits BCD only, 4 bits only. But here you have something called as a zonal code. Okay, so there is a zonal code which is going to contain 4 bits. So this zonal code is going to be the separator. It is going to separate the number with the next number. So the two numbers will be separated by a zonal code here, right? So you have a zonal code, you have a number, then a zonal code, then you have the digit, so and so on. Then one, but the last 4 bits will be used for what? A number only. We are going to have last 4 bits for a number, a digit. One before that, the 4 bits before that will be used for representing sign. Here also sign positive and negative. K for positive, BD for negative. CAFE for positive and BD for negative. So this is how you represent, right? So here also what you can do, you can give numbers, you can randomly give zeros and ones, but you should understand what is that you are doing. So if I have to say, for example, I have to convert 79 and give these numbers here. So, but it should have how many digits? 15 digits. So 15 digits should be used. So wherever there is 0 has to be filled, then it has to be filled with 0, so that you will represent 15 digits. So likewise you can give example for everything, right? Let us again summarize once. Short form fixed point number 16 bits, long form fixed point number 32 bits. So first bit is the sign bit, right? Decimal packed number, every number is going to be represented using 4 bits, right? Sign bits comes in the last. Sign bit also will be represented 4 bits. Unpacked will be separated by zonal codes. That's the only difference between packed and unpacked. Zonal codes also are going to be 4 bits, right? The sign will come one before the last digit. Sign also will be represented in 4 bits. Then short form floating point, so it's going to have two parts. One is character part, other one is the fraction part, right? So only thing you have to remember, it is 32 bits. So long form floating point 64 bits. Yes, so in both, first is a sign bit, next 8 will be character, and the rest will be fraction part, right? The last one is characters. Character, each and every alphabet is going to be represented using 88 bits, right? How many alphabets you can have maximum? You can have 256 alphabets. Yes, so this is one topic covered. What is it? Data formats. Just remember these formats, the diagrams names, done. Example, you can do it at that time. You can give your own example at that time, right? Yes. So the next thing I wanted to discuss with you is going to be data types. Sorry, data types we just discussed. So data formats is what we have discussed already. The next topic we'll be discussing is about your data. Basically, it is going to be about your data, where the data can be stored and what is the meaning of the way of storage, right? The first and foremost thing I wanted to tell you is data can be stored in two places. So in your code, in your program, whatever data you're going to store, we are going to either store it in a register or we are going to store it in a memory location. So the next topic, which is going to be instruction formats, will be based on these two things. So where am I going to store the data? I will store the data in the what? Register, and also I'm going to store it in a memory location. So register, you know already that there are 0 to 15, 16 registers in total, 0 to 15. So those registers also can contain data. Yes, you already know that. So apart from that, the data also can be stored where? In memory locations. The data also can be stored in a place called as a memory location. So now this particular slide is going to explain you how do you represent data, how that memory location is represented. Yes. So how are we going to represent memory location? So see here, there is an instruction here. It is a load instruction. Okay, L2 comma 904 of 0 comma 15. So we will leave the instruction part. We are not so much worried about the instruction part. What I wanted to tell you here is, here though in the previous example micro flowchart I said A2 comma 176, it is not represented 176. The actual format is first part 904 or 176, whatever it is called as the displacement or the offset. It is called as the displacement or the offset. That is the first part, so which is this one, right? So 904 is that part, right? So the second part is nothing but a register. Here what you have is a register. What you have here also is a register. What you have here is nothing but your what, offset or your displacement, right? So you have to understand what is this three things, why is in memory location represented like this, right? To do that, I wanted to give you an example first. Yes, let us say, take an example. Yes, so this is one familiar example. So this program. We are going to again see it in the future classes, but I think you would have come across this, right? So what is that I wanted to tell you is, let us take one example here, right? Let us take the same load example only. So we will see what is actually the meaning of this, right? So here 904 of 0 comma 1, that is where my number is. Okay, yesterday we discussed about relative address and absolute address. So if my number is at location 904, what is the meaning of it? 904 here is a relative address, so I have a data present in this location. Whatever data I have, let us say I have a number, say 5. So I'm not able to not I have not got used to this, right? So I have let us say number 5 is what is stored in 904. Okay, but in my instruction if I say, just say plainly 904, what happens after the program is loaded to the main memory? That time 904 may be something else. Okay, maybe your program is only loaded after 900, right? So 904 may not be the data which we are thinking or assuming. So there is going to be a problem. So what is that we are going to say here is, whenever I have to know where this data is present, so I have to take into consideration so many things. First thing is the displacement. What do you mean by displacement? It's also called as offset, but I will continue as displacement from now on. So what do you mean by displacement is, it's like you're reading a line from a textbook. So I want to tell you, all of you take your textbook, page number 125, all will have this 125. So I'm going to start reading some sentence. The system programming is a uh, interesting subject. It's the line I'm going to read. So the next question you will all ask me is, ma'am, which line is it? Okay, so I will have to tell you it is line number 20. So what you have to do, you have to start counting from 0, 1, 2, 3 and go to line number 20. This 20 is called as your displacement. So I'm already at location 0. So if I have to go to location 904, then 904 is the displacement. From 0 I will start and go to 904. That distance between 0 and whatever instruction you are talking about is your, the data or the instruction you're talking about, the address you're talking about is your displacement, right? That's it. Displacement just means where in your program, at which location in your program are you talking about. So I'm going to say in location 904 there is a data 5. I have to add that 5 to say 49. I have to add 5 to 49 is my program, let us assume. So 904 is the memory location, but that is only a relative address. It cannot be taken forward, because when I load it to the main memory, the address is going to change, right? How will I come to know what that address is? Okay, the basic thing you should understand here is something called as your base register. Yes, here we are going to use register 1 as the base register. Out of the 16 registers, register 1 is going to be used as your base register. So the first and foremost thing, you should know what is the base register and what is the value stored in base register. So this is the base register, here is register 1, and what is the value stored in base register? The value stored in base register is 48. That is where you are going to load your program, that is your main memory. So the address allotted for you to execute your program is at location 48, that is your base register value, right? So how will I get this absolute address? So there is one method of doing that is, I will add the displacement, right, with the base register value. So this is register 1's value. So I'll have to do what? I'll have to add the displacement with the register 1 value. So when I had 904 plus 48, I get 952. Yes, you understand? So in order to get the actual or your absolute address, so we have to give this whole format. Only then it is complete. Otherwise, it is not complete. Yes. Yes, but what is a 0? 0 is again a register. This particular register is called as an index register. This is called as an index register. It is only used, okay. Say for example, index register can be used for when storing numbers consecutively. My data is going to be stored consecutively, like you do in arrays, right? So then what happens? I will only say 904, but at 904, when the register zeros, which is the index register value, register 0, index register value is 0, then one number will be stored at 904. Okay, when the index register value is say 4, so what happens? At 908, second number will be stored. Index register value is going to be 8, and so on. So what happens? Index register value can be used in situations like when you're going to store consecutive data, then I will use my index register. So index register option also is there for you. So what happens? So what is the actual complete meaning of this particular storage format is? So if I have to get my absolute address, yes, I have to add my displacement plus the index register plus the base register, right? And normally index register value is going to be assumed to be 0. Okay, it is the register 0 is used as an index register, and the value of index register is always 0, only except in situations like you're going to handle an array kind of a thing, right? So otherwise index register value is going to be 0. That is why usually we will do, we will add what this particular displacement will usually be added with a base register, and then you will say, yeah, I got my absolute address. Okay, actually you're also adding the index register value, but here these places it is 0, so you don't bother much. You understand? Yes. So this is what I wanted to tell you. So here what is happening? Your address, usually your memory location will be represented like this. Example 904 of 0 comma 15. 904 is the displacement. 0 is the index register which you are going to use. So register 0 is what I'm using. That's not register, it's not 0, value 0. It is register 0 I'm using. 15 here is nothing but my base register. So mostly 15 will be the base register, which is the last register used as a base register. So if I have to get my absolute address, I have to add my displacement 904 plus contents of register 0, which is the index register, plus contents of base register, which is register 15. So only when I add all this, I will get my absolute address. See here, 904 plus 0. 904 is the displacement, 0 is your index register value, and 48 is going to be your what? Base register value. So this I get here, 952 is my absolute address. So that is why we are representing in like this format, right? So based on this, our next class we are going to discuss about instruction formats.